Bismillahirrahmanirrahim. Hello everyone. In this video tutorial I'm going to show you how to design a single footing using ASDIP foundation software. So this software is available in my Facebook page. You can download and install, and after that you can use another analysis software such as ETABS or SAP, then bring the data in a separate sheet, and then you can choose what kind of footing you want. So here is 5 type of footing. The first is split footing, that Raft foundation, and the second is strap footing and combined footing, as well as wall footing and pile cap footing. So in this tutorial, I want to design this footing. So I will give it footing number 1. So I suppose to have the length of the footing 2 meters, and the weight of the footing is 2 meters, and the column size is 40 by 40. So we have a live load which we got from the analysis. Actual load 120 kilonewtons and a dead load 150 kilonewtons, and the maximum moment is here in X direction and Z direction. And also we have this shear force, the soil cover which is which cover the footing is 30 centimeters, so the water content is assumed to be 60 centimeters. The soil pressure is 150 kilonewton per square meters, and friction angle is 28 degrees. So we suppose the concrete using C30 marks 30 megapascal, and FEY, which is the yield concrete C30, and FEY, which is the yield strength of the steel, we're using 415 megapascal. We go quickly to the software. First, here we can select split footing and give a name. F1, here is name, and we're gonna open the software. The first thing is the geometry. We can go to the design, choose the units, and I'm going to use SI units. Okay, and then I'm going to give the direction. This is X direction and this is Z direction. So the Z direction is 2 meters, and the X and Z direction both are 2 meters. The footing thickness is assumed 60 centimeters, and the soil cover is we already giving here 30 centimeters, and the water content is 60 meters. So I'm going to use 0, and the column size is we also have another option for steel column, but for our work we're using concrete. So this is the offset, which is this offset in Z. If there is any eccentricity in the column, you want the column should locate in somewhere else of this foundation, then you can give your required offset. But for me, I assume this is in center of the on this footing, so I give 0. So the next is the column geometry and foundation geometry is completed. We are going to the loading. For the dead load we have 150 kilonewtons, and the MEX is we can use 57, and MEZ is 26 kilonewtons times m meters, and shear force 25 and 50 in a Z direction shear force. And we have another live load which is just as axial force 120. So these two, we don't have another reduced live load or sun load or wind, so we assume this is other is 0. Just we have live load and dead load. The material we want to use is concrete grid 30 megapascal, and for the footing, and the rebar for yield strength is 415, and the concrete density is 2224 kilonewtons per cubic meters. And same we're using for column. And tensile, we also consider tensile yield strength, and concrete is density is same. Another parameter is that soil, we using soil pressure, which is 150. Soil pressure is 150, and the fraction coefficient is 0.7. We can select other like coarse granite cells, but the cell our foot is coarse granite soil, silt or soil. So the initial is 28 degrees. The soil cover density is, it can be 18 or 16 kilonewton per square, but it's 17 is okay. Now material is finished. We're going to reinforcing rebar. So from the column design, maybe we have some data how many rebars we have from the column. Now outer bar, which is in an X direction in this, and here's we can call the top. If you want to provide in the top reinforcement, then you can check. If you don't want to provide top, then you want to uncheck. The concrete cover is almost 8 centimeters, and the bar sizes, we can select number bar 20 and diameter is 20. In X, this is Z bar and this is X bar. And for the bottom, this is bottom and this is top, we're using the same. Top piece can be 6 centimeters, and here is using again 20, diameter 20. Do you want to have some sort of hooks or not in X line? If we provide hooks, that's be better in the top and the both direction in negative. One is negative, one is positive. So we want both should provide in XC. This is the rebar which we used top, bottom, and also with hooks. And going to for column, so the column is all using list 25 and using top. This is top bars and bottom bars for this side, for this side, for this side. So and also 2 in this side, 2 in the left in this. We actually have 6 numbers, and here is we have 4 numbers. So the concrete cover is 5 centimeters using the number 25. Sorry, ties is smaller. We're using D8. The here is finished the reinforcement. Now if you want to add some information, then you can add. Otherwise, like what kind of project is called, foundation, let's see, it's called John and foundation 1. If there is any note you can give. Here we can check the results, and the maximum bearing pressure is 164, which is not our is 150, but the maximum bearing pressure is, which is higher. So this load provide a higher pressure on the soil. So what we can do is we should change the geometry of footing, so that footing, when we increase this, so then the area increase, so the uh, the results will change and we get a lower pressure. Now let's see if we use just in one side and it's changed quietly. So now it's 100 st, which is quite good. For this allowable, and we got 109. Even for a high safety factor, this stability check is very high. So we can make it 220, and this is 130, and this is, but uplift safety factor is very less, so that's better to use even larger. So now the safety factor is still same, but if I used 70, this sliding safety factor increase and the uplift safety factor is because we have a larger moment, so we should uh, reduce or increase the match higher to check this, but it's okay, and the uplift safety factor is also okay. So now we can see another, the shear design is ratio is 0.9 is okay, and the punching is also okay, and the reinforcement is ratios very 0, which is we have a lot of provided moments, which giving top and bottom, rebounds, and in the z direction, and all these parameters quite well, and the column is also uh, okay. We have 150, it's 200, which is quite higher, and actual strength is very high, and this is now we can check one by one and see uh, each pause separately, and we can see the soil pressure and the combination 1D1, and also we can get other like punching shear and all these another data. So here is some more detail, which is with all the equations used in this designing parts, and here is the final, which is our project. So the first thing is the geometry of loading, and this is the graph of pressure, which this part is leasing, here is higher, and this is the location of column and the size of the column quite well. So now we can see one-way shear results. This is the one-way shear results, and the shear is here 117.1, and here is list, which is we see. And here is the pinching graph. So the pinching is 1.2 meters far away the column, and the bending, so this is the region for bending, which will bend, and here is the column capacities, interaction curves. We can see the column is very high, which strength is very high, and we have in this point. So our concrete is in this point. So this is very good. So the construction is like this. We have a 50 centimeters foundation, and this is 30, then it will be soil, and the oak from the column comes like this, and the rebar. So this is the final step, which is going to construct. Now this is done, we can print a detailed report from our foundation. Okay. We can call it design of foundation 1, and we can see all the graphs and equation which used in this design parts, so you can see in the results. Here is completed. So the project's name, engineers, and also the dates, everything. So the geometries. So the result is very comprehensive, and you can understand each steps when you design a foundation, and also the drawing. So this is very quick and also effective and reliable. So each equation they use, they giving a reference, like using HCI equation 20. Each equation, each expression, they giving the reference, which is exactly you can search and also check, calculate handy, and see the result. So this is the end of the tutorial. If there is any question, please put in the comment and I will find time to answer your question. And see you next time.